In this video, we're going to talk about finding the distance between 2 points and then also finding the midpoints between 2 points. So there are two different instances where you're going to be finding the distance and the midpoint. One is on a number line, which is just basically having one coordinate, okay? And the other one is finding the distance between 2 points on a coordinate plane where you have both an x and a y um, value. Okay, so finding the distance on a number line is really very easily found because all you do is you just subtract your two values and take the absolute value of it. You might be asking, well, why do you want to take the absolute value? Well, the reason you want to take the absolute value is because distance can never be a negative number. Okay, distance can never be a negative number. So obviously, if you take the absolute value of it, that takes that out of the equation. All right, so pause the video and copy this definition into your notes. All right, so what is the distance between Q and R? Well, Q is -6 minus -3. Okay, and we're going to take the absolute value of that. So -6, so keep, change, change. So -6 plus 3 is -3. And the absolute value of -3 is 3. So that's how you do it algebraically. If you want to just check yourself, well, let's see, how many spaces are there between Q and R? 1, 2, 3. So there's 3 spaces between Q and R. So that distance is 3. What's the difference between A and X? Well, A is -5 minus X, which is 3. All right? -5 minus 3 is simply -8, all right? Because you do your keep, change, change, keep, change, change. -5 plus -3 is -8. But the absolute value of -8 is just simply 8. If you count the spaces, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 spaces. So that distance is is 8. All right? The second instance that we're going to find distance is on the coordinate plane. And to do that on the coordinate plane, we're going to use the distance formula. This is a formula that you're going to use the rest of this course. This is a very important formula for you to memorize and to know. Okay, so pause the video before I explain sort of the theory behind the distance formula. Pause the video and copy this distance formula into your notes in a prominent place. Okay. Now that you've done that, the distance formula is derived from the Pythagorean theorem, and the only reason I'm going into that is because sometimes, and I'll show you on the first example that we're doing there, sometimes you can actually use the Pythagorean theorem in order to find the distance. So if we want to find, suppose the distance from here to here, that distance right there, okay? You know that the Pythagorean theorem, you learned about this in middle school, the Pythagorean theorem says that if you have a right triangle, then if you say take side A or leg A, square it, plus leg B, square it, that gives you the hypotenuse, or C, the longest side, squared. All right? Well, so now we're going to say, well, what is A? Well, if you look at a coordinate plane, this is just a horizontal. This is a horizontal number line. So from what we just learned, we said, how do we find the distance on a number line? Well, you subtract the two endpoints, okay? And so we're going to say this minus this, but then we're going to square it. And when we square it, okay, so that's your distance A. Okay, when we square, that takes care of if there were any negatives or not. Okay, so obviously distance cannot be negative. All right, so B is our vertical side. Okay, once again, that's our y values. on the coordinate plane. Vertical is our y values. Okay, and then c, the distance we're actually trying to find, is actually what we say is the distance. Now, it says it's distance squared. Well, we don't really care what distance squared is. We just want to find the value of the distance. So to undo a square, you take the square root. You learned that in Algebra 1. So if you take the square root, that cancels out with the squared, and we're just left with the distance. Okay, so the distance formula says that it's the square root of x2 minus x1, the x values squared, plus y2 minus y1 squared. Okay, and we're going to do several examples, and you'll see what that means. Okay, so if we say what is the distance between points P and Q when P is at 3, 4 and Q is at 7, 2. So distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so once again, we can plug it into that, or we can just simply say, well, let's see here. If we draw a right triangle, this is the hypotenuse. It's pretty easy to see that this is 1, 2, 1, 2, 3, 4. So this the length of this is 4. The height is 2. So we can say, well, this is 4 squared plus 2 squared. That's going to give us distance squared, all right, by using, this is using the Pythagorean theorem, a squared, or let me write it in the same way. So c squared is equal to a squared plus b squared, okay? So when we do that, so d squared is 16 plus 4, all right? 16 plus 4, and when we do that, we end up with d squared is equal to 20. Take the square root of it, take the square root of that, and we can see that this cancels with this, and d is equal to the square root of 20. And if we use our handy dandy little calculator here, okay, and we plug in 20 and find the square root of it, we can see that that's equal to approximately 4.47 or 4.5. Okay, so approximately equal to 4.5. And we did that. If we would have used the distance formula, we would have done done the same thing to get your 4 squared and your 2 squared. Okay, so if we would have said x2 minus x1, that's 7 minus 3. Okay, so that would have been 4. That's this. And if we would have said 2 minus 4, which would have been negative 2, okay? So we could have said, and this could have been negative 2, but because we're taking absolute value, it doesn't matter, or because we're squaring it, it doesn't matter. Okay? So that would have been negative 2 squared, which would have been positive 4. Okay? So it's all the same thing. All right. So this is one where we're going to go ahead and we don't have it drawn out on a coordinate plane, but if we're going to find the differences in the x values, so we're going to say 3 minus negative 4 plus negative 1 minus 1. Okay, don't forget to square it. Okay, plus plus. So that's square root of 3 plus 4 is 7 squared plus negative 2 squared. This is a negative 2. Now, remember, this negative 2, you have to, if you plug it into a calculator, you have to make sure you put that negative 2 in parentheses. Otherwise, it'll give you a negative value, which is not the case. Okay, 7 squared is 49, plus negative 2 squared is 4. So that is a square root of 53. Plug it into our calculator. 53 square root is 7.3, roughly. Okay, approximately 7.3. Okay, midpoint formula. Okay, midpoint formula. That's the distance that's exactly halfway between the two endpoints. All right, so go ahead and make sure that you copy this into your notes. All right, copy this into your notes. The midpoint formula is just simply adding the two endpoints and then dividing it by 2. All right, that's on a number line. All right. So here, find the midpoint of RT. R is right here. T is right here. That's negative 2 and 4. So negative 2 plus 4, divide that by 2. Okay, negative 2 plus 4 is 2 divided by 2, and that is equal to 1. So that, in this case, if you look at it, that would be right. That would be right here. Okay. If you look, there's 1, 2, 3 spaces left, 1, 2, 3 spaces to the right. So that S is exactly halfway. Now, in this example, there happened to be a point at that midpoint. It doesn't necessarily always have to be that way. Okay. QS, Q is negative 6. S, in this case, is 1. Okay, so we have negative 6 plus 1 divided by 2. Negative 6 plus 1 is negative 5 over 2, which is 2.5. Negative 2 and 1/2. All right, so if we look at negative 2 and 1/2, that would be right in here. So it's a half, 1, 2, 3, half, 1, 2, 3. So that is the midpoint. All right. Midpoint formula on a coordinate plane. And there again, this is the same exact thing that we were looking at when we were talking about the Pythagorean theorem. Using the Pythagorean theorem, we're just finding the distances on your x value on the horizontal line or horizontal axis and on the vertical axis. Okay, so copy this into your notes. Okay, so right. So the only difference here is that we have two. We're going to have two values that we're working with, an x value and a y value, instead of just the one. All right. And the important thing here is that the midpoint coordinate is written as an ordered pair, just like that. All right. Find the coordinates of the midpoint of a line segment GH when G is at 8, negative 6. Okay, so this is x and y. This is x and y. And h is at the point of negative 14, 12. Okay, so we're going to do x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And that's, so when we do that, x values, so 8 plus negative 14 divided by 2. And when we solve that, 8 plus negative 14 is, signs are different, so we're going to subtract it. So that gives us negative 6 over 2, which is negative 3. So our x value is negative 3. Our y value, we have negative 6 plus 12 divided by 2. Negative 6 plus 12 is a positive 6 over 2. And that is a positive 3. So the midpoint is at negative 3, 3 on the coordinate plane. All right, one last example. Okay, find the coordinates of the midpoint of the segment WX when W is at 12, 2 and X is at 7, 9. Label your points X, Y, X, Y. I found that it's always good to label your points when you're adding or subtracting. That way you don't make careless errors. Okay, so this is nice because they're all positive. Okay, remember our formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. All right, so we end up with 12 plus 7 divided by 2, which is 19 divided by 2. Or if when we do that, that is 9.5. All right. Then we do our y values. 2 plus 9 divided by 2. We do that as 11 divided by 2, which is 5.5. All right. So that's it for this video dealing with distance and midpoints. Make sure that you've got all those things written down that I've asked you to copy into your notes, and make sure you ask me any questions if you have questions, and we'll talk to y'all later.